July 16, 1943, RAF Molesworth, England. Dawn was still 2 hours away as Master Sergeant William "Billy" Tucker worked beneath the harsh glow of portable floodlights, his hands steady despite the biting cold that had settled over the airfield. Frost glittered on the wings of the B-17 flying fortresses, lined up in neat rows, each bomber a $300. Their investment in America's promise to bring the war to Hitler's doorstep. Tucker believed, like everyone else, that these magnificent machines represented the absolute pinnacle of American engineering ingenuity. He could not possibly imagine that by the end of summer, his own hands would revolutionize their most critical component, using nothing but discarded scrap and mathematics that his segregated schoolhouse had never taught him. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the extraordinary account of how one man's desperate innovation not only extended bomber flight range by 60 critical minutes, but fundamentally transformed the way Allied forces understood the relationship between maintenance and combat effectiveness, ultimately saving thousands of lives and helping turn the tide of the air war over Europe. The 351st Bombardment Group had been at RAF Molesworth for only 4 months, flying missions deep into Nazi-occupied territory. The demands of daylight precision bombing meant pushing both men and machines to their absolute limits. The B-17s, for all their legendary ruggedness, were proving vulnerable in ways that the designers back in America could never have anticipated. Colonel James Ironjaw Harding stalked through the pre-dawn darkness toward the operations building, his breath forming clouds in the frigid English air. At 53, Harding was older than most group commanders, with weathered features that bore the permanent imprint of years spent squinting into the sun at 25,000 feet. A veteran of the First World War, he had been flying since the days of canvas and wood biplanes. Now he commanded 36 four-engine bombers, each carrying a crew of 10 men and a 6,000-pound bomb load. "Weather report?" he barked as he entered the crowded briefing room. Major Leonard Wilson, the group meteorological officer, looked up from his charts. "High-pressure system over the channel, sir. Visibility unlimited above 20,000 feet. Ground fog over most of Germany, but Bremen should be clear by 1100 hours. Winds aloft from the northeast at 35 knots. Harding nodded grimly. Bremen again. The northern German port city housed the Focke-Wulf factory and was one of the most heavily defended targets in the Reich. 3 previous attempts by the 8th Air Force had resulted in unacceptable losses. Today would be different. It had to be. "Fuel calculations?" Harding asked, turning to Captain Edwin Parker, the group operations officer. Parker, a former mathematics professor from Princeton who had joined the Army Air Forces immediately after Pearl Harbor, adjusted his wire-rimmed glasses. "Standard load plus 250 gallons in the Tokyo tanks, sir. That gives us approximately 30 minutes of reserve fuel after returning to base, assuming normal consumption rates and standard route." Harding frowned. "Not enough. Weather could change. We might need to divert." He studied the map on the wall, the red string marking their intended route deep into enemy territory. "And if those new reports about increased fighter presence around Bremen are accurate, we'll need more time to assemble the formation after bombing." "Sir, we're already at maximum capacity," Parker protested. "The engineers say—" "I know what the engineers say," Harding interrupted. "But I also know that every B-17 that runs out of fuel 20 miles from the English coast might as well have been shot down over the target. Find me more range, Parker." As the briefing continued, 300 yards away in Hangar C, Master Sergeant William Tucker had already been working for 2 hours. At 29, Tucker was the oldest and most experienced crew chief in the 351st's maintenance section. Before the war, he had worked as a mechanic at Robbins Field in Georgia, maintaining crop dusters and the occasional Lockheed Electra. Despite his expertise, the Army Air Forces had initially refused to accept him as anything but a stevedore. It had taken the personal intervention of his former employer, a crop duster pilot turned lieutenant colonel, to get him assigned to aircraft maintenance. Even then, Tucker had faced the daily struggle of being one of only 11 black mechanics in the entire 8th Air Force. His crew was segregated, sleeping in separate quarters and eating at separate times from the white mechanics. Yet the B-17s didn't seem to care about the color of the hands that maintained them, and Tucker's bombers consistently had the highest operational readiness rate in the group. Tonight, Tucker was focused on the propeller hub of the No. 3 engine on Southern Comfort, the B-17 assigned to Lieutenant Matthew Reynolds and his crew. The massive Hamilton Standard hydromatic propellers, nearly 13 feet in diameter, were engineering marvels, automatically adjusting their pitch to maintain optimal engine performance under varying conditions. But they were also maddeningly complex and prone to hydraulic leaks that could cause catastrophic failures. Tucker had noticed that after approximately 7 hours of operation, the propeller hubs would begin to seep hydraulic fluid around the blade roots, causing the pitch mechanism to become sluggish and reducing engine efficiency. "Hand me that torque wrench, Jenkins," Tucker said to Private First Class Calvin Jenkins, his assistant. Jenkins, a 19-year-old from South Carolina who had been working with Tucker for the past 3 months, passed the tool. "You really think this is going to work, Sarge? The tech manual doesn't say nothing about this kind of modification." Tucker smiled slightly. "The tech manual was written by fellas who've never had to keep these birds flying through a European winter with half the parts we need. Sometimes you gotta improvise." What Tucker was attempting had never been documented in any maintenance manual. Using salvaged copper shim stock from a damaged P-47 Thunderbolt fighter, he was fabricating custom seals for the propeller hub. The standard rubber O-rings supplied by Hamilton Standard hardened in cold temperatures, causing microscopic gaps that allowed hydraulic fluid to seep out. Tucker's copper shims, when precisely fitted and used in conjunction with a special graphite-based lubricant he had developed, created a more resilient seal. The science behind Tucker's innovation was sound, though he would have been hard-pressed to explain it in formal engineering terms. Growing up in rural Georgia, formal education had been limited for a black child. But Tucker had an intuitive understanding of mechanical systems that bordered on the extraordinary. He could diagnose engine problems by sound alone and often seemed to commune with the machines he maintained. "This'll give her another 60 minutes of optimal performance," Tucker explained as he carefully inserted the custom shim. "Might not seem like much, but that's the difference between making it home and ditching in the North Sea." As dawn approached, the airfield came alive with activity. Ground crews swarmed around the B-17s, loading bombs and ammunition, checking systems, and preparing the massive bombers for the day's mission. Lieutenant Matthew Reynolds and his crew arrived at Southern Comfort as Tucker was completing his work. Reynolds, a 24-year-old former bank clerk from Ohio, had flown 15 missions as aircraft commander. Tall and lanky with a perpetual 5 o'clock shadow, he had the haunted eyes of a man who had seen too much death too quickly. "She ready to go, Sarge?" Reynolds asked, performing his pre-flight walk-around inspection. Tucker nodded, wiping his hands on a rag. "Yes, sir. Made some adjustments to the No. 3 prop that should improve your fuel consumption. You might get an extra hour of flight time if you're careful with your throttle settings." Reynolds raised an eyebrow. "An hour? That's significant. What kind of adjustments?" Tucker hesitated. His modifications weren't approved by technical order, and officially, he should have submitted any proposed changes through proper channels, a process that typically took months. "Just some fine-tuning of the hydraulic system, sir. Nothing that affects safety." Reynolds studied Tucker's face for a moment, then nodded. Like most pilots, he had learned to trust his ground crew chief implicitly. The relationship between the men who flew the bombers and those who maintained them was sacred, built on mutual dependence and trust. "I appreciate it, Sarge. Every minute counts when you're over enemy territory." As Reynolds climbed into the aircraft, Tucker caught the sidelong glances from some of the white ground crew members working on adjacent aircraft. His innovations were viewed with suspicion by many, not because they weren't effective, but because of who had developed them. Technical Sergeant Frank Miller, a crew chief from Kansas who maintained the B-17 Lucky Lady, approached as Tucker was packing up his tools. "Heard you're messing with the props again, Tucker," Miller said, his tone neutral but his expression skeptical. "Brigade Engineering says those seals can't be modified." Tucker continued cleaning his tools, his expression carefully composed. "Not modifying the seals, just supplementing them. Nothing in the manual says you can't add a secondary seal system. Miller shrugged. Your funeral if that prop fails. Reynolds is a good pilot. Be a shame if your tinkering put his crew at risk. The comment stung, but Tucker had heard variations of it many times before. The implication was clear. A black mechanic couldn't possibly understand the complexities of aircraft systems better than the white engineers who had designed them. Every modification I've made has improved performance, Miller. Check the mission readiness records if you don't believe me. Miller walked away without responding, and Tucker returned to his work. The exchange was typical of the casual racism he encountered daily, but he had long ago learned to focus on results rather than recognition. His bombers came back, and the numbers spoke for themselves. Aircraft maintained by Tucker's team had a 23% lower abort rate than the group average. At 0600 hours, the first B-17 roared down the runway, its four Wright Cyclone engines thundering as it clawed its way into the grey English sky. One by one, the massive bombers took off at precisely timed intervals, gradually forming up into the combat box formation that was their primary defense against enemy fighters. Inside Southern Comfort, Lieutenant Reynolds and his co-pilot, Second Lieutenant Thomas Wilson, worked in practiced harmony, easing the fully loaded bomber into the air. At maximum takeoff weight of 65,000 pounds, with 780 gallons of fuel and 6,000 pounds of bombs, the B-17 demanded every ounce of power from its engines. "Gear up," Reynolds ordered as they cleared the runway. "Flaps up, let's get her cleaned up." In the top turret behind the cockpit, Technical Sergeant Oscar Leibowitz, the flight engineer, monitored the engine gauges. All engines in the green, Skipper. Oil pressure, manifold pressure, and RPM all nominal. Reynolds nodded. "Keep an eye on number 3. Tucker made some modifications to the prop. As Southern Comfort climbed to join the formation, Technical Sergeant James Washington settled into his position at the radio desk. A 32-year-old former postal worker from Chicago, Washington, was the only black crew member aboard. Despite his rank and critical role as the aircraft's communications specialist, he too experienced the segregation that defined military life for black servicemen. On the ground, he ate and slept separately from his crewmates. In the air, however, such distinctions faded. Combat created its own brotherhood. Washington checked his equipment methodically, ensuring all frequencies were properly set. Through his headphones came the controlled chaos of dozens of bombers forming up, pilots calling positions, navigators confirming headings, and the constant background chatter of a massive aerial armada preparing for battle. By 0645, the 351st's 36 bombers had joined the larger formation of the 1st Bomb Wing. From the ground, they appeared as tiny silver crosses against the brightening sky, their contrails forming white streaks that gradually merged into a single enormous vapor trail pointing toward Germany. Colonel Harding, flying as an observer in the lead aircraft, surveyed the formation with grim satisfaction. 374 B-17s were en route to Bremen today, the largest raid yet mounted by the 8th Air Force. They would be escorted by P-47 Thunderbolts for the first 150 miles, but after that, they would be on their own until they reached the target. The P-47s lacked the range to go all the way to Bremen and back. At RAF Molesworth, Master Sergeant Tucker had no time to watch the bombers disappear to the east. Already he was preparing for their return, organizing his maintenance crews and ensuring they had the necessary parts and equipment to repair the damage that would inevitably come. "Jenkins," he called to his assistant, "round up every piece of copper sheet we've got. When those birds get back, we're going to have work to do." For the next several hours, Tucker and his team prepared. They knew from experience that at least a third of the returning bombers would have battle damage requiring immediate repair. Another third would have mechanical issues that needed addressing before the next mission. Only a lucky few would return, needing nothing more than refueling and rearming. Meanwhile, high over the North Sea, the bomber formation continued eastward. Inside Southern Comfort, the crew settled into the routine of a long mission. The 4 gunners, Staff Sergeant Robert McCluskey in the ball turret, Staff Sergeant Henry Goldstein in the tail, Sergeant Donald Peters in the right waist position, and Sergeant Victor Kaminsky in the left waist, checked and rechecked their .50 caliber machine guns. In the plexiglass nose, Bombardier Lieutenant Frank Martinez and Navigator Lieutenant William Chen studied their charts and instruments. "Fuel consumption looking good," Leibowitz reported from the top turret. "Better than usual, actually. All 4 engines running about 7% more efficiently than standard." Reynolds nodded, making a mental note to thank Tucker when they returned. The bomber's Wright R-1820 Cyclone engines each consumed approximately 50 gallons of fuel per hour at cruise power. A 7% improvement might not sound significant, but multiplied across 4 engines over an 8-hour mission, it translated to potentially crucial additional range. 3 hours into the flight, the P-47 Escort reached the limit of their range and reluctantly turned back toward England. Lieutenant Wilson, the co-pilot, watched them go with a sense of foreboding. "Fighters at 7 o'clock high." The warning from Goldstein in the tail position shattered the relative calm. "Looks like Fokker-Wulf 190s, about 20 of them." "Battle stations," Reynolds ordered calmly. "Close it up tight. Everyone. Remember your training." The German fighters attacked from the rear, the preferred tactic against bomber formations. The FW-190s dove through the formation at high speed, their 20mm cannons flashing. The air filled with the hammering sound of hundreds of 50-caliber machine guns as the bombers defended themselves. Southern Comfort shuddered as several 20mm shells struck the left wing, tearing holes in the aluminum skin, but fortunately missing any critical components. Sergeant Kaminsky at the left waist position was thrown to the floor as a shell fragment pierced the fuselage inches from his head. "You okay, Kaminsky?" called Peters from the right waist position. "Yeah, just a scratch," Kaminsky replied, though blood was flowing freely from a cut on his forehead. He resumed his position at the gun, tracking a FW-190 that flashed past. The first fighter attack lasted less than 2 minutes, but seemed like an eternity. When it was over, 2 B-17s were missing from the formation, spiraling down trailing smoke and flames. 3 others had suffered significant damage, but remained airborne. "Damage report," Reynolds called over the interphone. "Left wing has some holes, but control surfaces are responding normally," reported Leibowitz. "Fuel tanks appear intact. Some hydraulic lines might be damaged, but backup systems are functioning." The formation continued toward Bremen, the remaining crews grimly determined. They were still over 100 miles from the target when the second fighter attack came, this time from Messerschmitt Bf-109s. The air battle intensified as they approached Bremen. The Luftwaffe, determined to protect the vital Fokker-Wulf factory, threw everything they had at the bomber formation. By the time they reached the initial point, where the bombing run would begin, the first bomb wing had lost 17 B-17s and dozens more were damaged. "Starting bomb run," announced Martinez from the Bombardier's position. "I have control." Reynolds surrendered control of the aircraft to the Bombardier, who would now fly the bomber using the Norden bomb site for the critical minutes of the bombing run. The formation had to fly straight and level during this period, making them particularly vulnerable to flak and fighter attacks. The sky around Bremen was filled with black puffs of flak, deadly 88mm anti-aircraft shells exploding at the precise altitude of the bomber formation. Each explosion sent jagged steel fragments in all directions, capable of tearing through aluminum aircraft skin like paper. Southern Comfort rocked violently as a flak burst exploded directly beneath the aircraft. Warning lights illuminated in the cockpit as the No. 2 engine began streaming oil. "Feathering No. 2, Reynolds announced, shutting down the damaged engine and feathering its propeller to reduce drag. Operating on 3 engines would significantly increase fuel consumption, exactly the situation Tucker's modifications were designed to mitigate. "Bombs away," Martinez called as Southern Comfort released its payload of 12 500-pound general-purpose bombs. Freed of the weight, the bomber lurched upward slightly. "Let's get the hell out of here," Reynolds said, banking the aircraft to the prescribed heading that would take them back to England. All around them, other bombers were doing the same, the formation beginning to lose its cohesion as damaged aircraft struggled to maintain position. The return journey proved even more harrowing. German fighters, reinforced and refueled, continued to press their attacks. The surviving bombers, many damaged and operating on reduced power, struggled to defend themselves. 2 hours from the English coast, fuel became a critical concern for many crews. The combination of combat maneuvering, damage, and adverse winds had increased fuel consumption beyond the planned parameters. Over the radio, desperate calls began. "Skipper, we're down to 400 gallon, reported a pilot from Memphis Bell 2. "Roger that," responded the wing commander. "All aircraft with critical fuel status drop to 10,007 feet and proceed directly to nearest English airfield. The rest maintain formation." Aboard Southern Comfort, despite operating on 3 engines, fuel consumption remained manageable thanks to Tucker's modifications. The improved efficiency of the remaining 3 engines partially compensated for the loss of the 4th. "Fuel status?" Reynolds asked Leibowitz. 800 gallons remaining, the flight engineer reported. "We're burning about 180 gallons per hour on 3 engines. Should be enough to get home with some reserve." Reynolds nodded, relieved. Without Tucker's modifications, they would likely have been among the aircraft forced to descend and risk the gauntlet of German fighters that often waited below the main formation to pick off stragglers. As they approached the English coast, more problems developed. The hydraulic system, damaged by flak, began to lose pressure. The landing gear would have to be lowered using the emergency system, and the flaps might not function at all. "Prepare for a no-flaps landing," Reynolds warned his crew. "It's going to be fast and hot." The damaged bombers began to divert to emergency airfields along the English coast. Southern Comfort, still in relatively good condition despite its battle damage, continued toward RAF Molesworth. On the ground, Tucker and his team had been monitoring the radio reports. They knew that many aircraft had been lost or damaged, and they prepared accordingly. As the first bombers began to appear as tiny dots on the eastern horizon, ambulances and fire trucks took position along the runway. "Here they come," Jenkins said, squinting into the distance. Tucker nodded, his expression grim. "Not as many as left." One by one, the surviving B-17s of the 351st circled the field and landed. Some came in with engines out, others with holes torn in their fuselage or wings. A few had wounded crewmen, requiring immediate medical attention. Each landing was a testament to the ruggedness of the B-17 design and the skill of its crews. Southern Comfort was among the last to arrive, its distinctive paint scheme recognizable even at a distance. Tucker watched anxiously as Reynolds brought the damaged bomber in for landing. With no flaps and 1 engine out, the aircraft was moving considerably faster than normal as it touched down. The landing was rough but controlled, the B-17 using nearly the entire length of the runway before coming to a stop. Tucker and his team rushed to the aircraft as the exhausted crew began to emerge. Lieutenant Reynolds was the last to exit, his face streaked with grime and fatigue. "Your modifications saved us, Sarge," Reynolds said without preamble. "We lost an engine over the target and had battle damage to the hydraulic system. Without that extra fuel efficiency, we'd have ditched in the channel." Tucker nodded, pleased but already focused on assessing the damage. "Glad to hear it worked, sir. We'll get her patched up for the next mission." The debriefing revealed the full extent of the day's losses. Of the 374 B-17s that had departed that morning, 60 had been shot down, a devastating 16% loss rate. Another 138 had suffered damage significant enough to require major repairs before flying again. The human cost was even more sobering: 600 airmen killed, missing, or wounded. Colonel Harding, grim-faced and exhausted, listened to the reports from his group. The 351st had lost 5 aircraft, with 7 more seriously damaged. Yet their bombing results had been among the best in the wing, with most bombs falling within 1,000 feet of the aiming point. "What about fuel consumption?" Harding asked, remembering his earlier concerns. "Did any of our birds ditch due to fuel exhaustion?" Major Parker consulted his notes. "No, sir. In fact, our aircraft reported better than expected fuel efficiency." Lieutenant Reynolds, in Southern Comfort, landed with 220 gallons remaining, despite operating on 3 engines for most of the return journey. That's almost an hour's worth of additional flight time. Harding's eyebrows rose. "How is that possible? Did they fly a different route?" "No, sir. Apparently, Sergeant Tucker in maintenance made some modifications to the propeller systems. Several of our aircraft had similar results, approximately 7 to 10% improvement in fuel efficiency." Harding's interest was immediately piqued, Any modification that could extend the range of his bombers by an hour or more was potentially game-changing. In an air war where every mile and minute counted, such an advantage could mean the difference between success and failure, between life and death for his crews. "I want to see Tucker in my office at 800 tomorrow," Harding ordered, "and I want complete technical details of whatever modifications he's made." The next morning, Master Sergeant Tucker reported to Colonel Harding's office as ordered. Despite his rank and experience, he felt the familiar knot of anxiety in his stomach that always accompanied interactions with senior officers. Being summoned to the group commander's office was unprecedented. "Sergeant Tucker reporting as ordered, sir," he said, standing at attention before Harding's desk. Colonel Harding looked up from the papers he was studying. "At ease, Sergeant. Take a seat." He gestured to the chair opposite his desk. Tucker sat stiffly, his cap held in his hands. "I've been looking at the after-action reports from yesterday's mission," Harding began. "Several aircraft, including Reynolds's Southern Comfort, reported unusually good fuel efficiency. I'm told you're responsible." "Yes, sir," Tucker replied cautiously. "I implemented some modifications to the propeller hub sealing system that reduces hydraulic fluid leakage and improves efficiency." "Without proper authorization," Harding noted, his tone neutral. Tucker tensed. "Yes, sir. I understand the proper channels for modification proposals, but our operational tempo didn't allow for the usual approval process. Given the urgent need for extended range, I made a judgment call." Harding studied the black sergeant thoughtfully. The military, like American society at large, was strictly segregated. Black servicemen rarely received recognition for their contributions, and their initiatives were often dismissed or appropriated. Yet the results of Tucker's modifications were undeniable. "Explain the technical details," Harding requested. For the next 20 minutes, Tucker outlined his modifications in precise technical language. He described how the standard rubber O-rings in the propeller hubs degraded under the extreme temperature variations experienced during high-altitude missions, causing microscopic leaks that allowed hydraulic fluid to escape. His copper shim supplementary seals, combined with the graphite lubricant he had developed, created a more resilient system that maintained optimal propeller pitch control throughout the mission profile. Harding listened intently, occasionally asking technical questions that revealed his own deep understanding of aircraft systems. When Tucker finished his explanation, the colonel leaned back in his chair. "How long have you been implementing these modifications?" Harding asked. 3 weeks, sir. I started with my assigned aircraft, then expanded to the rest of my maintenance section. Currently, 14 aircraft in the group have the modified seal system." Harding nodded. "And the performance data? Average fuel efficiency improvement of 3% across all modified aircraft, sir. Translated to operational terms, that's approximately 45 to 60 minutes of additional flight time, depending on load and conditions." The colonel stood and walked to the window, looking out at the flight line where ground crews were already preparing aircraft for the day's mission. After a moment, he turned back to Tucker. "Your initiative may have saved several crews yesterday, Sergeant. That additional endurance meant the difference between ditching and making it home for at least 3 of our aircraft." "Thank you, sir," Tucker replied, still uncertain where this conversation was heading. "I'm authorizing immediate implementation of your modifications across the entire group," Harding announced. "Furthermore, I'm recommending to Wing Headquarters that the modification be standardized throughout the 8th Air Force." Tucker blinked in surprise. "Sir, Thank you, sir." Harding held up a hand. "There's more. I'm also recommending you for a promotion to Master Technical Sergeant and the Bronze Star for your contribution to the war effort." The recognition was unprecedented. Black servicemen rarely received decorations, particularly for technical innovations rather than combat actions. Tucker struggled to maintain his composure. "I appreciate the recognition, sir, but I was just doing my job." Harding shook his head slightly. "No, Sergeant, you went well beyond your job. You saw a problem, developed a solution, and implemented it at considerable personal risk. Had your modification failed, you would have faced a court-martial. That kind of initiative and courage deserves recognition, regardless of." He left the sentence unfinished, but both men understood the unspoken reference to Tucker's race. "Thank you, sir," Tucker said simply. "I need complete technical documentation by 1600 today," Harding continued, returning to practical matters. "Diagrams, materials, specifications, installation procedures. Everything a standard maintenance crew would need to implement the modification correctly. Can you provide that?" "Yes, sir. I've already prepared most of the documentation." "Good. Dismissed, Sergeant." As Tucker left the office, he felt a complex mix of emotions. Pride in his work being recognized, certainly, but also a keen awareness that his achievement would be viewed through the lens of his race. He had no illusions that one technical innovation, however valuable, would significantly change the deeply entrenched racial hierarchies of the military or American society. News of Tucker's innovation and Colonel Harding's endorsement spread quickly through the 351st Bomb Group. Reactions were mixed, reflecting the complicated racial dynamics of the time. Some white mechanics, like Technical Sergeant Miller, were openly skeptical. "Copper shims? That's your big innovation?" Miller scoffed, as Tucker's team demonstrated the installation procedure to other maintenance crews later that day. "Any first-year apprentice could have thought of that." "Then why didn't they?" countered Staff Sergeant Wilson, one of the white mechanics who had seen the results firsthand. "Tucker's birds consistently have the best performance stats in the group. Maybe you should be taking notes instead of running your mouth." The exchange was typical of the tensions that simmered beneath the surface, yet as the modification was implemented across more aircraft and the performance data became irrefutable, even the skeptics were forced to acknowledge its value. Lieutenant Reynolds sought out Tucker after learning of his commendation. "Heard about your Bronze Star, Sarge. Well deserved." Tucker, who was elbow-deep in an engine cowling, looked up in surprise. "Word travels fast around here." Reynolds smiled slightly. "No secrets on an airbase. What you did, it's going to save lives. My crew and I owe you a debt." Tucker shrugged, uncomfortable with the praise. "Just doing what needed to be done, sir." "Well, keep doing it," Reynolds said, clapping him on the shoulder. "We're counting on you." The interaction was significant, not just for its content, but for its context. A white officer publicly acknowledging the contribution of a black non-commissioned officer represented a small but meaningful breach in the rigid segregation that defined military life. Over the next several days, the entire 351st Bomb Group's fleet was modified according to Tucker's specifications. The timing proved fortuitous, as 8th Air Force Headquarters announced a major operation targeting the Schweinfurt ball-bearing factories deep inside Germany. The mission would push the B-17s to the very limits of their range, making every drop of fuel crucial. On August 17, 1943, the 8th Air Force launched the Schweinfurt-Regensburg mission, one of the most ambitious and ultimately costly operations of the air war. 376 B-17s set out to strike these critical industrial targets, flying without fighter escort for much of the journey due to the extreme range involved. Colonel Harding, flying as an observer in the lead aircraft, watched as his group formed up in the early morning light. Every aircraft in the 351st now incorporated Tucker's propeller modifications, giving them a critical edge in endurance. Whether it would be enough remained to be seen. The mission unfolded as a brutal demonstration of the air war's realities. German fighters swarmed the bomber formations, taking a terrible toll. Flak over the targets was intense, filling the sky with deadly black puffs. By the time the survivors turned back toward England, 60 bombers had already been lost. The true test of Tucker's modifications came during the long journey home. The combination of combat maneuvering, battle damage, and headwinds had pushed fuel consumption beyond planned parameters for many aircraft. For the 351st, however, the improved efficiency provided a crucial margin. Radio calls from distressed aircraft filled the airwaves as fuel gauges approached empty. "Mayday, mayday, this is Devil's Due. Fuel critical. Ditching in channel position." Such calls were notably absent from the 351st's frequency. Despite heavy battle damage and multiple aircraft operating on 3 engines, they maintained enough reserve fuel to reach England. When the final count was tallied, the cost of the Schweinfurt-Regensburg mission was staggering. 60 bombers lost, 600 men killed, missing, or captured. Yet amid this disaster, the 351st's performance stood out. Despite facing the same opposition as other groups, every aircraft that survived the gauntlet of German fighters and flak made it back to base. None lost to fuel exhaustion. In the debriefing room, Colonel Harding addressed his weary crews. "Gentlemen, today was a hard day. We lost good men and good aircraft. But I want you to know that every one of our birds that survived the fighters and flak made it home because of the extra endurance provided by Sergeant Tucker's modifications. Without that additional hour of flight time, we would have lost at least 7 more crews." The recognition was unusual and significant. By explicitly crediting Tucker by name to the assembled aircrews, Harding was making a statement about the value of contributions regardless of race. Later that evening, as Tucker and his maintenance crews worked through the night to repair battle-damaged aircraft, a delegation of pilots appeared in the hangar. Led by Lieutenant Reynolds, they approached Tucker's workstation. "Sergeant Tucker," Reynolds said formally, "the pilots of the 351st wanted to thank you personally." He held out a brown paper package. "This isn't much, but we wanted you to know what your work means to us." Tucker accepted the package hesitantly and unwrapped it. Inside was a leather flight jacket, similar to those worn by the aircrews but modified with the maintenance insignia. On the back, hand-painted in vivid colors, was an image of a B-17 and the words, "An hour more," a simple but powerful recognition of what Tucker's innovation had provided. "We all signed it," Reynolds said, indicating the inside of the jacket, where dozens of signatures covered the lining. Every pilot and crew member in the group. Tucker was momentarily speechless. In the rigidly segregated military, such a gesture crossed boundaries rarely breached. "I don't know what to say, sir." "You don't need to say anything," Reynolds replied. "Just keep doing what you're doing. We'll keep flying them. You keep fixing them. And together we'll end this war." The moment represented more than personal recognition for Tucker. It symbolized a subtle shift in relationships, a crack in the foundation of segregation that defined American military service. Word of the 351st's superior endurance performance reached 8th Air Force headquarters, prompting an official inquiry. A team of engineers from Wright Field was dispatched to RAF Molesworth to investigate Tucker's modifications. Led by Major Howard Blackburn, a pre-war aeronautical engineer from Curtiss-Wright, the team arrived with a healthy dose of skepticism. "I understand you've developed some kind of propeller seal modification," Blackburn said to Tucker during their initial meeting, his tone suggesting he expected to find a crude field expedient rather than a legitimate innovation. "Yes, sir," Tucker replied evenly. "Would you like to see the installation process?" For the next hour, Tucker demonstrated the modification in detail, explaining each step and the technical reasoning behind it. Blackburn and his team observed in silence, occasionally exchanging glances as the complexity and elegance of Tucker's solution became apparent. "This is considerably more sophisticated than I was led to believe," Blackburn admitted finally. "Where did you receive your engineering training, Sergeant?" "No formal training, sir," Tucker replied. "Just experience and observation. 17 years working on aircraft engines, starting with crop dusters back in Georgia." Blackburn looked surprised. "You developed this sealing system without formal engineering background?" "Yes, sir, though I had some help from the physics books in the base library. Needed to understand the thermal expansion coefficients of the different metals." The exchange highlighted the disconnect between formal credentials and practical expertise, a disparity often exacerbated by the racial inequalities in educational opportunity. Tucker's intuitive grasp of mechanical principles, honed through years of hands-on experience, had led him to a solution that had eluded formally trained engineers. Blackburn's team spent 3 days at Molesworth, rigorously testing the modified aircraft and comparing their performance data with unmodified B-17s brought in from other groups. Their findings confirmed what the 351st already knew. Tucker's modifications consistently improved fuel efficiency by 7 to 10%, translating to approximately 45 to 60 minutes of additional flight time. On their final day, Blackburn sought out Tucker at his workshop. "We're recommending immediate implementation of your modification throughout the 8th Air Force," he announced without preamble. "The technical merit is undeniable." Tucker nodded, continuing to work on the engine component in front of him. Thank you, sir. Blackburn hesitated, then added, "There's also the matter of official credit and potential patent implications. Normally, innovations developed during wartime service remain property of the United States government, but the inventor is acknowledged in the official technical orders." This got Tucker's full attention. "Sir, the modified seal system will be designated the Tucker seal in all technical documentation," Blackburn explained. "Your name will be on every B-17 maintenance manual from now on." The recognition was unprecedented for a black serviceman. Tucker's innovation would not be appropriated or attributed to others, as so often happened with contributions from black Americans. "I appreciate that, sir," Tucker said quietly. "Though I didn't do it for recognition." Blackburn nodded. "Few true innovators do, Sergeant. They solve problems because problems need solving." He extended his hand, another small but significant breach of the usual racial etiquette. "On behalf of the Army Air Force's Engineering Division, thank you." As Blackburn's team departed, Tucker reflected on the strange path that had led him here, from a segregated Georgia schoolhouse to an English airfield, from being refused service at Southern diners to having his name immortalized in technical manuals. His journey embodied both the limitations imposed by American racism and the occasional individual transcendence of those limitations. The broader impact of Tucker's innovation became apparent in the following months. As the Tucker seal was implemented across the 8th Air Force, bomber endurance increased significantly, allowing for deeper penetrations into enemy territory and greater flexibility in routing and mission planning. The additional hour of flight time translated directly to increased operational capabilities and, more importantly, improved survival rates for crews forced to divert due to battle damage or weather. In late September 1943, Colonel Harding assembled the 351st for a formal ceremony. Standing on a makeshift platform before the assembled bombers and their crews, he addressed the group. "Today we recognize exceptional service and innovation," Harding announced. "Master Technical Sergeant William Tucker front and center." Tucker stepped forward, his uniform immaculate, his expression composed despite the unprecedented nature of the moment. As a black non-commissioned officer being publicly honored, he was acutely aware of the symbolism inherent in the ceremony. "For exceptional technical innovation and dedication to duty, it is my privilege to present Master Technical Sergeant William Tucker with the Bronze Star," Harding declared, pinning the medal to Tucker's chest. Sergeant Tucker's propeller seal modification has been adopted throughout the 8th Air Force and has already saved numerous aircraft and crews. His contribution represents the highest traditions of the United States Army Air Forces. The assembled personnel applauded, the sound echoing across the airfield. For many of the white servicemen present, it was a complex moment, recognition of a black man's achievement that challenged ingrained prejudices and assumptions. Following the official ceremony, Lieutenant Reynolds approached Tucker. "Congratulations, Sarge. Well deserved." "Thank you, sir," Tucker replied, "though I still think it's excessive for just doing my job." Reynolds shook his head. "It's not excessive. Your job saved my life and the lives of my crew. Without that extra hour of endurance, we'd have ditched in the North Sea after Bremen." He paused, then added more quietly, "You know, when this war is over, things will have to change back home. Men like you have proven too valuable for the old ways to continue." Tucker's expression remained neutral. He had heard similar sentiments before, usually well-intentioned but naive about the depth and persistence of American racism. "Perhaps, sir. We'll see." The exchange highlighted the fundamental disconnect in how white and black Americans viewed the war's potential impact on race relations. For many white servicemen, the shared experiences of combat and the demonstrated capabilities of black troops suggested a natural evolution toward greater equality. For black servicemen like Tucker, the daily reality of continued segregation and discrimination, even in the midst of war, tempered such optimism. As 1943 progressed toward winter, the air war over Europe intensified. The implementation of Tucker's propeller modifications coincided with other significant developments in the strategic bombing campaign. The introduction of drop tanks for escort fighters, The arrival of the P-51 Mustang with its exceptional range, and the gradual shift in tactics based on hard-earned experience. The 351st continued to fly missions deep into Germany, their aircraft now instantly recognizable by the distinctive Tucker seal insignia that the ground crews had begun painting near the propeller hubs. The symbol, a stylized TS in a circle, became a point of pride for the group, a visual reminder of their technological edge. For Tucker himself, the recognition brought both opportunities and challenges. His promotion to Master Technical Sergeant gave him greater authority within the maintenance section, but also increased the resentment from some white, non-commissioned officers now technically subordinate to him. "Don't see why a colored boy gets to give orders," Technical Sergeant Miller complained one evening in the NCO club, a facility Tucker himself could not enter due to segregation policies. Staff Sergeant Wilson, who had become one of Tucker's strongest advocates, challenged the comment. "That colored boy has forgotten more about aircraft engines than you'll ever know, Miller. His modifications are saving lives every mission. What have you contributed lately besides hot air?" Such exchanges reflected the complicated dynamics of a military simultaneously fighting fascism abroad while maintaining racial hierarchies at home. The contradictions were inescapable and increasingly difficult to justify. In November 1943, Tucker received unexpected news. He was being temporarily transferred to Wright Field in Dayton, Ohio, to assist the engineering division in further developing his propeller innovations. The assignment represented a remarkable acknowledgement of his expertise, placing him in direct collaboration with the Army Air Force's top engineers. Colonel Harding personally informed Tucker of the transfer. "This is an opportunity to expand your innovation to other aircraft types," Harding explained. "They're looking at adapting the Tucker seal for the B-24, P-47, and potentially the new B-29. Tucker nodded, processing the implications. "When do I leave, sir?" 3 days. Your orders are being cut now." Harding studied the sergeant thoughtfully. "You understand what this represents, don't you, Tucker? They're not just implementing your design, they want your expertise. That's virtually unprecedented." "Yes, sir, I understand." Tucker paused, then added, "Will I be returning to the 351st after this assignment?" "That's the plan. This is a temporary duty assignment, not a permanent transfer. We're not giving up our secret weapon permanently." Harding smiled slightly. "Though I expect you'll have your pick of assignments after this. Wright Field might try to keep you." The conversation highlighted how Tucker's technical contributions had created opportunities that would normally have been closed to a black serviceman. Merit had carved a narrow path through institutional racism, though the path remained exceptional rather than systematic. Tucker's departure from RAF Molesworth was marked by an informal gathering of the maintenance crews and several pilots who had come to respect his work. Private Jenkins, now a corporal thanks to Tucker's recommendation, seemed particularly affected. "Don't know how we'll manage without you, Sarge," Jenkins said, his voice unsteady. Tucker smiled reassuringly. "You'll manage just fine. I've taught you everything I know about those propeller hubs. Just follow the procedures we've established." Lieutenant Reynolds approached, extending his hand. "Good luck at Wright Field, Sarge. Show those engineers what real innovation looks like." Tucker shook the offered hand, nodding. "I'll do my best, sir." As Tucker boarded the C-47 transport that would take him first to London and then on to the United States, he carried with him more than just his duffel bag. He carried the knowledge that his work had made a measurable difference in the air war, that his name would be permanently associated with a significant technical innovation, and that he had earned respect, based solely on his skills and contributions. The flight to the United States gave Tucker time to reflect on the strange journey his life had taken. Born in rural Georgia, to parents who had themselves been born into slavery, he had grown up with limited educational opportunities, but an innate mechanical aptitude. His first exposure to aircraft had come at age 12, when a barnstorming pilot had landed in a field near his home. Something about the elegant machinery of flight had captured his imagination, setting him on a path that eventually led to maintaining crop dusters and, when war came, to the Army Air Forces. Now, approaching Wright Field, the nerve center of American military aircraft development, he wondered how he would be received. Would the engineers there see past his race to recognize his expertise, as Colonel Harding had, or would he face the more typical dismissal and marginalization? The answer proved to be complicated. Tucker's arrival at Wright Field in late November 1943 generated considerable curiosity. His reputation as the developer of the Tucker seal had preceded him, creating a dissonance between expectations based on his technical contributions and preconceptions based on his race. Major Blackburn, who had evaluated the propeller modifications at Molesworth, met Tucker at the airfield. "Welcome to Wright Field, Sergeant. I hope you had a pleasant journey." "Yes, sir, thank you. We've set up workspace for you in Hangar C. The engineering team is eager to collaborate on adapting your sealing system to other aircraft types." The use of the word collaborate was significant, suggesting a partnership rather than simply having Tucker demonstrate his technique for others to document. Yet as they walked across the base, Tucker couldn't help noticing the stares and double takes his presence generated. A black sergeant being escorted by a white major, clearly as a colleague rather than a subordinate, violated the expected social order. The engineering team assembled in Hangar C consisted of 6 officers and 3 civilian engineers, all white and all initially skeptical of Tucker's credentials. Captain Edward Ramsey, the team leader, made little effort to hide his doubts. "So you're the miracle worker from England," Ramsey said, his tone making clear his skepticism. "Major Blackburn tells me you developed a propeller seal modification that's giving B-17s an extra hour of endurance. Quite remarkable for a field expedient." The pause before field expedient clearly replaced a different, less diplomatic characterization. Tucker had encountered similar attitudes throughout his military service and had developed a standard approach. Let the work speak for itself. "Yes, sir. Would you like me to explain the technical principles involved?" Tucker replied evenly. For the next 30 minutes, he outlined the engineering challenges of maintaining hydraulic pressure in propeller hubs under extreme temperature variations, the limitations of standard rubber O-rings, and the theoretical basis for his copper shim supplementary seal system. He drew diagrams, referenced thermal expansion coefficients, and explained the mathematical models he had developed to predict performance under different conditions. The engineer's expressions gradually shifted from skepticism to surprise and finally to respect, as Tucker demonstrated a depth of technical knowledge that belied his lack of formal education. By the end of his presentation, even Captain Ramsey was engaged, asking detailed questions about specific aspects of the design. "This is considerably more sophisticated than I expected," Ramsey admitted. "Where did you study engineering, Sergeant?" "I didn't, sir," Tucker replied. "Experience and self-study." Ramsey shook his head slightly, reassessing his assumptions. "Well, theory is one thing. Let's see the practical application. We have a B-17 propeller hub set up for disassembly. Perhaps you could demonstrate the installation process." The demonstration further cemented Tucker's credibility. His hands moved with the practiced precision of someone who had performed the procedure dozens of times, his explanations clear and thorough. The engineers watched attentively, occasionally exchanging glances that acknowledged they were witnessing exceptional expertise. Over the following weeks, Tucker worked closely with the Wright Field team to adapt his sealing system to other aircraft types. Each presented unique challenges. The Pratt & Whitney R1830 engines on the B-24 Liberator used a different propeller hub design than the B-17's Wright Cyclones. The P-47 Thunderbolt's massive R2800 engine operated at higher RPMs, creating different stress patterns. And the new B-29 Super Fortress, still in development, used revolutionary new engine and propeller systems. The collaboration was productive but not without tension. Some members of the team, particularly Lieutenant Gregory Wells, a recent engineering graduate from MIT, seemed unable to accept Tucker's expertise at face value. "I still don't see how you developed this without formal training," Wells commented during a test session. "These calculations for thermal expansion would require advanced mathematics." Tucker continued adjusting the test apparatus. "Mathematics is just a formal language for describing relationships that exist whether we name them or not," he replied. "I may not know the official terms, but I understand the relationships." Major Blackburn, Overhearing the exchange, intervened. "Wells, Tucker's modifications have been proven effective in combat conditions. That's the only validation that matters here." Despite such occasional frictions, the project progressed rapidly. By mid-December, the team had successfully adapted the Tucker seal for the B-24 and P-47, with promising early results for the B-29 prototype. Performance testing showed consistent improvements in fuel efficiency across all platforms: 7–10% for the B-17 and B-24, 5–8% for the P-47, and a projected 6–9% for the B-29. The practical implications were significant. For heavy bombers, the increased efficiency translated directly to extended range or heavier bomb loads. For fighters like the P-47, notorious for their limited range compared to the P-51 Mustang, even a modest improvement in fuel efficiency could make a critical difference in their ability to escort bombers deeper into enemy territory. Tucker's experience at Wright Field illustrated both the opportunities and limitations available to black servicemen during World War II. His technical contributions were recognized and valued, creating a space where he could collaborate with white officers and engineers on relatively equal terms. Yet outside that narrow professional context, the structures of segregation remained firmly in place. He ate in separate facilities, slept in segregated quarters, and faced restrictions on his movements off base. When the engineering team went to dinner in Dayton to celebrate a successful test series, Tucker could not join them because the restaurant did not serve black customers. Such contradictions, being essential to the war effort yet denied basic dignities, typified the experience of black Americans in uniform. In early January 1944, with the adaptation work largely complete and ready for production implementation, Tucker prepared to return to England and the 351st Bomb Group. Before his departure, Major Blackburn informed him of a final recognition. "The official technical order implementing your sealing system across all Army Air Forces aircraft will be published next week," Blackburn explained. "It will be designated Technical Order 4236-157, Tucker Auxiliary Propeller Hub Sealing System. Your name will be listed as the primary developer." Tucker nodded, appreciating the significance of the acknowledgement. "Thank you, sir." Blackburn hesitated, then added, "There's also this." He handed Tucker an envelope bearing the letterhead of the Army Air Force's Technical Service Command. Inside was a certificate acknowledging Tucker's contribution to the war effort, signed by Major General Charles E. Branshaw, Commanding General of the Technical Service Command. Accompanying the certificate was a letter offering Tucker a civilian position as a technical consultant after the war. "They want to keep your expertise in the post-war Air Force," Blackburn explained. "It's virtually unprecedented for a non-commissioned officer, particularly." "A colored non-commissioned officer," Tucker completed the thought. Blackburn nodded uncomfortably. "Yes, the point is, your work has opened doors that might otherwise have remained closed." The offer represented both an opportunity and a dilemma for Tucker. A civilian technical position would provide security and continuation of the professional respect he had earned. Yet it would also place him in an environment where he would likely remain an exception, the one black face in rooms full of white engineers, forever having to prove and reprove his competence. "I'll consider it, sir," Tucker said, carefully folding the letter and placing it in his pocket. Tucker returned to RAF Molesworth in mid-January 1944 to find the air war over Europe transformed. The arrival of P-51 Mustangs, with their exceptional range, had changed the equation dramatically, allowing escort fighters to accompany bombers all the way to targets deep inside Germany. Combined with improved tactics and the gradual erosion of the Luftwaffe's strength, bomber losses had decreased significantly. Yet the fundamental work of keeping the massive B-17s flying continued unabated. Tucker resumed his role as maintenance chief, now with the additional authority that came from having his name on an official technical order. The Tucker seal had been implemented throughout the 8th Air Force, and the results were undeniable. Extended range, improved reliability, and ultimately, lives saved. Colonel Harding, who had been promoted to full colonel during Tucker's absence, welcomed him back personally. "Glad to have you back, Master Sergeant. Wright Field tried to keep you permanently, but I insisted you belonged with the 351st. Thank you, sir. Feels good to be back. Harding studied Tucker thoughtfully. Your work has made a difference, you know. The statistics are clear. Since implementing your modifications across the group, we've had 0 losses due to fuel exhaustion. That translates to approximately 30 aircraft and 300 men who might otherwise have ditched in the North Sea. The numbers were sobering, a concrete measure of human impact that transcended the technical specifications and efficiency percentages. Never thought about it in those terms, sir, Tucker admitted. You should. Every innovation that extends range, improves reliability, or increases survivability saves lives. That's the real measure of your contribution. As Tucker resumed his duties, he found subtle changes in how he was perceived. His work at Wright Field and the official adoption of the Tucker Seal throughout the Army Air Forces had elevated his status beyond what his rank alone would confer. White mechanics who had previously been skeptical or dismissive now sought his advice on technical matters. Pilots greeted him with respect that went beyond the usual courtesy shown to ground crew, yet the fundamental structures of segregation remained firmly in place. Tucker still slept in segregated quarters, still ate at separate times from white servicemen, still faced the myriad daily reminders that America's military, like America itself, maintained rigid racial hierarchies, even while fighting a war against fascist racism. The contradiction was thrown into sharp relief in February 1944, when Stars and Stripes, the U.S. Armed Forces newspaper, published an article about the Tucker Seal and its impact on bomber operations. The article included a photograph of Tucker alongside a partially disassembled propeller hub and praised his innovation as a significant enhancement to our strategic bombing capabilities. The day after the article appeared, Tucker was approached by Corporal Jenkins, his former assistant who had been promoted during Tucker's absence. "Seen the article, Sarge?" Jenkins asked, holding out a copy of the newspaper. Tucker nodded. "Saw it this morning." "First time I've ever seen a colored man in Stars and Stripes who wasn't Joe Louis," Jenkins commented. "You're famous now." Tucker smiled slightly. "Hardly famous, just did what needed doing." "Still, it's something, ain't it? Your name in the paper, your name on the technical order. Makes a difference for fellas like me seeing that." The comment highlighted an aspect of Tucker's achievement he had not fully considered, its symbolic importance to other black servicemen. In a military that offered limited recognition and advancement to black troops, his success represented a rare acknowledgement of black contribution and capability. Later that same day, Technical Sergeant Miller, who had been among the most skeptical of Tucker's innovations, approached him in the maintenance hangar. "Saw your write-up in Stars and Stripes," Miller said, his tone neutral. "Yes," Tucker replied cautiously, unsure of Miller's intent. "Look, I wasn't sure about your modifications at first," Miller admitted. "Thought it was some kind of shortcut that might put crews at risk. I was wrong about that." He paused, then extended his hand. "Good work, Tucker." The gesture, simple as it was, represented a small but meaningful breach in the wall of prejudice. Tucker accepted the handshake, nodding acknowledgement. No grand declarations of racial equality. No sudden transformations of deeply held beliefs. Just a small professional recognition of competence and contribution. As the air war progressed through 1944, the strategic impact of extended bomber range became increasingly apparent. The ability to strike deeper into Germany with greater precision and lower losses gradually eroded the Nazi war machine's industrial base. Tucker's modification, combined with other technical improvements and tactical innovations, contributed to this growing Allied advantage. In March 1944, Lieutenant Reynolds and his crew completed their 25th and final mission, becoming one of the first crews in the 351st to complete a full tour without a single mechanical abort, a testament to Tucker's maintenance standards. Before departing for the United States, Reynolds sought out Tucker one last time. "Wanted to say goodbye and thank you, Sarge," Reynolds said. "Your work kept us flying when a lot of other crews didn't make it." "Just doing my job, sir," Tucker replied, the response automatic by now. Reynolds shook his head. "No, it was more than that. What you did changed things. Not just the propeller seals, but how you did it, proving that innovation can come from anywhere, from anyone willing to look at a problem differently. The observation captured something essential about Tucker's contribution. Beyond the specific technical innovation, his work had demonstrated that expertise and insight were not confined to those with formal credentials or social privilege. As the war in Europe moved toward its conclusion in 1944 and early 1945, the legacy of the Tucker seal continued to expand. The modification was incorporated into production specifications for new aircraft, becoming a standard feature rather than a field modification. The estimated impact across the 8th and 15th Air Forces was significant. Hundreds of aircraft saved from fuel exhaustion. Thousands of crewmen spared the terror of ditching in hostile waters. For Tucker personally, the recognition brought opportunities previously unimaginable. The offer of a civilian technical position with the Army Air Forces after the war remained open. Additionally, several aircraft manufacturers had expressed interest in hiring him as a consultant, having seen the practical value of his innovation. Yet Tucker harbored no illusions about the limitations that would still constrain his opportunities in post-war America. The doors that had opened for him were exceptions, based on his specific contribution, not systematic changes in how Black Americans were perceived or treated. In April 1945, as Nazi Germany neared collapse, Colonel Harding called Tucker to his office once more. "I've been instructed to inform you that you're being rotated back to the United States," Harding announced. "Wright Field has requested you specifically for work on the new bomber designs." Tucker received the news with mixed emotions. "When do I leave, sir?" 3 days. Your orders just came through." Harding stood and extended his hand. "It's been an honor serving with you, Master Sergeant. Your contribution to this group and to the 8th Air Force has been extraordinary." Tucker accepted the handshake, nodding. "Thank you, sir. It's been an honor for me as well." Before his departure, Tucker was surprised by an informal gathering organized by the maintenance crews. Both black and white mechanics assembled in Hangar C, along with several pilots and flight crews, to bid farewell to the man whose innovation had become synonymous with the 351st's reputation for technical excellence. Corporal Jenkins, now a staff sergeant, presented Tucker with a memento, a propeller hub bearing plate that had been polished and engraved with the words "Tucker Seal, an hour more," and the signatures of the entire maintenance section. "So you don't forget where it all started, Sarge," Jenkins said, his voice thick with emotion. Tucker accepted the gift, deeply moved by the recognition from his peers. "I couldn't forget if I tried," he replied. The gathering was remarkable not just for its sentiment, but for its composition. In the segregated military, such integrated social events were rare and usually discouraged. That it occurred without official sanction spoke to the respect Tucker had earned across racial lines. Tucker's return to the United States in May 1945 coincided with the final collapse of Nazi Germany. The war in Europe was over, though the conflict with Japan continued in the Pacific. At Wright Field, Tucker joined a team working on propulsion systems for next-generation bombers designed for the planned invasion of Japan, an invasion rendered unnecessary by the atomic bombings of Hiroshima and Nagasaki in August. With the war's end came the inevitable demobilization and restructuring of the military. Millions of servicemen and women returned to civilian life, including Tucker, who was honorably discharged in November 1945 with the rank of Master Technical Sergeant, the Bronze Star, and several commendations. The post-war world offered both opportunities and disappointments for Tucker and other black veterans. The technical expertise and proven capabilities they had demonstrated during the war opened some doors that had previously been closed. Tucker himself accepted a position with Hamilton Standard, the manufacturer of propellers for most American military and commercial aircraft, becoming one of their first black technical consultants. Yet the broader structures of American racial segregation remained largely intact. The GI Bill, which provided educational and housing benefits to veterans, was administered in ways that often excluded black veterans from its full advantages. Jim Crow laws continued to restrict where black Americans could live, work, and receive education. The military itself, despite the contributions of black servicemen, remained segregated until President Truman's Executive Order 9981 in 1948. Tucker's professional success represented both an exceptional achievement and a reminder of how much talent had been suppressed by systemic racism. For every William Tucker whose innovation was recognized and implemented, countless others had been denied opportunities to develop and apply their abilities. The Tucker seal remained in use on propeller aircraft throughout the post-war period and into the jet age, eventually becoming such a standard feature that its origins were largely forgotten, except by aviation historians and the dwindling number of World War II veterans who had benefited directly from its implementation. In 1962, nearly 20 years after his innovation had first been implemented on B-17s over Europe, Tucker was invited to the newly established Air Force Museum in Dayton, Ohio, to participate in the restoration of a B-17G being prepared for display. The aircraft, named Shoo 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 Baby after a popular song, had flown with the 91st Bomb Group during the war and had been among the first to receive the Tucker seal modification. As Tucker worked alongside younger mechanics who knew the technical specifications but not the history behind them, he reflected on the strange journey that had brought him from a segregated Georgia schoolhouse to this moment. His innovation had outlived the war that spawned it, becoming part of aviation's technical evolution. More importantly, perhaps, it had helped demonstrate that talent and innovation could emerge from unexpected sources when given the opportunity to flourish. The full impact of Tucker's contribution extended beyond the specific technical improvement he had developed. It served as a small but significant example of how artificial barriers based on race limited not just individuals, but society's collective progress. Each person denied the opportunity to contribute their talents represented not just a personal loss, but a diminishment of human potential. As post-war America gradually and painfully confronted its racial contradictions through the civil rights movement and beyond, stories like Tucker's served as reminders of both what had been accomplished under difficult circumstances and what might have been possible in a more just and equal society. The legacy of William Tucker and his insane propeller repair ultimately transcended the specific technical problem it solved. It became a testament to human ingenuity, to the power of practical knowledge combined with theoretical understanding, and to the undeniable truth that innovation recognizes no racial boundaries, even when society does. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.